8.3, similar polygons. Use the information given to list all pairs of congruent angles and write the statement statement of proportionality, helps if I read all the words, for the figures. So number 8, triangle DEF is similar to triangle PQR. And they want us to write everything that's like congruent to each other, equal to each other, all those things. So we know that if they are similar, then all their angles have to be congruent. So that means that angle D is congruent to angle P. Angle E is congruent to angle Q. And angle F is congruent to angle R. And then the way that we write the proportionality statements are we take 2 of the letters and we write it over the 2 of the other one, and then we go on and so forth until we've hit all the sides. So if the triangle, we're going to have 3 sets. Obviously, if it's a quadrilateral, it's going to have 4, so on and so forth. Pretty much the biggest thing we're dealing with is like a pentagon. But anyways, so we would have DE over PQ is equal to EF over QR is equal to DF over PR. So the proportion of the sides should all be the same. So whatever DE over PQ is, that's going to be the same like proportion as EF over QR, and so on and so forth. The next problem say to decide whether the quadrilaterals are similar. So basically they've drawn 4 what looks to be rectangles. They aren't, based on markings, all rectangles, but I'm just going to draw the ones that we're going to need. So we're going to need, for number 12, ABCD and JKLM. So the 2... one's facing this way, and the other one is like this. So this would have been all given information here. Alright, so I'm trying to determine if these are similar or not, and not in the sense that we use the word of like, oh, they're similar because they're both rectangles, like talking similar in the sense of geometry. And so the way that we figure this out is we're going to look at the sides, like the longest sides over the shortest sides. So we're going to look at 7 over 5, and that should be equal to 3.5 over 3. But do those things reduce to give us the same thing? Nope. So these are not equal. So that means that the answer is no, because the lengths of the corresponding sides are not proportional. So like I said, for these problems for 11 through 14, they've given you 4 quadrilaterals. I just didn't want to draw all 4 of them since we only were going to need 2 of them for what we were doing. But you're answering questions like this for the different ones that they have being quote-unquote similar to each other, and you're determining if they are or not. The next ones they give us, it's pretty much the similar thing. Similar. Decide whether the polygons are similar. If so, write a similarity statement. And so they're going to give us what kind of look like they're two rectangles. They may not be. It's not a square. This is not supposed to be a square, but it keeps turning it into a square. So just, you'll see when I put the values on here, but. All right, so I'm looking at this to determine if these are similar or not. So they're not obviously facing the same way, but since they kind of appear, aside from this one, to be rectangles, then I would take the longest sides and like put them over each other, and then the shortest sides put them over each other, and then they should reduce to be the same if they are similar. So we would have in this case what would be WV over FG, so that would be 6 over 4 is equal to UV over HG, so 4 over 3. Can either of these be reduced any farther?
Well, 6 over 4 can. 3 over 2.
Yeah, this would become 3 over 2. Is 3 over 2 equal to 4 over 3? Nope, so we would say no, or not similar or something like that. The next problems, it's going to be 5 problems back to back that we're going to do, and there's like 2 chunks of these problems, so we're going to do one of the sets and then y'all are going to do one of the sets, but it's going to be obviously even and odd problems because of how it comes together. But I'll draw the pictures first. So this is for 19 through 23. It says that PQRS is similar to JKLM. I'll give you a second to get all that copied down. And we'll look at the problems. And what I would tell you is ones like this or something similar, when I went and looked at the quiz review, because we'll be having a quiz on Tuesday. I don't remember if that's the date that's up there or not. I think originally I thought it was going to be on Monday, but it's going to be on Tuesday. But when I look at the problems that go with this stuff for the quiz review, it's very similar to this type of question here. So if you haven't been paying attention, whatever, I would definitely pay attention here with these ones. All right, so question 19 says to find the scale factor PQRS to JKLM. So that means that the PQRS this is not a triangle, quadrilateral should be the one that is on top, and then the JKLM is going to be the one on the bottom. Okay, and then 20, we're going to flip it. So this means that I need to look at something that I have both of the values. And I say that because if you notice, I have a Y, I have an X, and I have a W here. So I need to look at the sides that don't have a variable because I can't relate them yet because I don't know what these values are. So the only sides where they're both a number and not a variable are these top ones. So I'm looking at KL and QR, but I need QR to be on top because it's PQRS to JKLM. So we're going to have 12 over 15, which would reduce to what?
4 over 5.
4 over 5. And so then the way that we write our answer to write a scale factor is we write 4:5. So that means 4 to 5 is our scale factor for going from PQRS to JKLM. We're going to flip it. The scale factor for JKLM to PQRS. So I'm going to pretend for a second that we haven't done 19. And so again, I can only go with the top ones here. So I'm going to have, in this case, 15/12, which reduces to 5/4, which means that my scale factor is 5:4. Okay, now, obviously, if I've already gone from PQRS to JKLM and then they tell me to flip it, I could just go straight from 4 to 5 to 5 to 4, and that would be fine. But I just wanted us to talk through it again so that you have it, because there's not a lot of like examples with this stuff in here. All right, 21, they want the values of W, X, and Y. So any ideas how I might go about solving these things?
Geometry.
Well,
Use the scale factor
yes.
that we had.
I can use the scale factor. I can also relate it to something else that I already had. Is that what you're going to say? So we'll start with W. So I need W and 25, and it doesn't matter. I just need to start with the same one each time. It would be much easier if I start with W being on the top, right, mathematically. So I'm going to do W over 25 is equal to, I can either use my scale factor and say 4 to 5, or I can go back over here and say 12/15, which I know is going to reduce to 4/5. You just have to make sure you do it in the right order. So in this case, I started with this. I keep wanting to say a triangle, and I know it's not a triangle. I started over here with this one, PQRS, so that means I would need this scale factor of 4/5, which I can do. So 4/5. And then I just need to algebraically multiply both sides by 25. So over here, I'm left with W. 5 goes into 25 5 times. 4 times 5 is 20, so W is equal to 20. And then to find X, how would I set up X?
X over 10 is equal to 5/4.
Yep. So we swapped them this time and used 5/4 because I'm starting over here with X on top. So that means that I have to start with the one where JKLM was first. So we're starting with 5/4. And so then multiply by 10. So I have X is equal to, if you want to write this as like 50/4, you want to go ahead and reduce. So this, if I take a 2 out of all this, 2 and 5, and then that gives me 25/2, which as a decimal would be what?
12.5.
12.5. Those of you that have had me in algebra know that I usually like improper fractions, but for the sake of it being like a value of a side length, it's better for it to be a decimal. So 12.5, and then lastly I need to find Y. How would I set that one up?
Same way you did X.
Y over 16
Yep.
is equal to 5/4.
Yep. So X and Y came off the same one, so I'm using the same thing here. I just have Y over 16, obviously, instead of X over 10. Multiply by 16. 4 goes into 16 4 times. 5 times 4 is 20, so Y is equal to 20. Questions on how we found any of those values or similarities or anything? All right, the next part of the question 22 says to find the perimeter of each. So I would recommend that you maybe say like the perimeter of JKLM or something like that, just so that you're specifying which one's which. So JKLM, X was 12.5 and Y was 20, so I would probably go up here and just write 12.5 and 20. How do I find the perimeter of this shape?
Add all the sides.
Yep, just add all the sides up. So it's going to be, to look at my paper, 25 plus 20 plus 12.5 plus 15. That was all the sides, right? 25, 15, 20, and 12.5. Yep, okay. Since I have to scroll, I have to make sure I get them all. 72.5. So that's the perimeter of JKLM. And then I'll do the same thing, but for the other one, to the perimeter of PQRS. So then I've got 12 plus 10 plus 16 plus 20. And so that perimeter is 58. So then 23 says to find the ratio of the perimeter of PQRS to JKLM. Kind of shortening it a little bit in how it's written. So that means that I would have 58 over 72.5, technically. Okay, I take the perimeter of PQRS and I put it over the perimeter of JKLM. But if I know that these two shapes are similar to each other, and I've shown what their factor is, so 4 over 5 or 5 over 4, which in this case it would be the one that's 4 over 5, then that means that if the sides are all a factor of 4 over 5, the perimeter also should be. Okay, so this would reduce to 4 over 5. And obviously that's not necessarily a way that we would normally reduce it, but if we were to take and we were to divide them both by the same thing, then we would get to that. It actually ends up being, if I remember correctly, like 14.5 that you're technically dividing by to get that. But I'm telling you that if the sides are similar, which they are, the perimeters will always be similar as well. Okay, so that's just something to keep in mind as we go into the quiz next week and you're doing those problems, okay? Because this is, I wouldn't even need to look at this part. I could just go straight to 4 over 5 because if that's the factor for the sides, it's also the factor for the perimeters. For the perimeters? As long as you've already shown like this up here, one way or the other, yeah, because the perimeters, I'm telling you, the perimeters are going to be the same. So yeah, that's fine. Because it took me a minute to figure out what I needed to divide by to get this to be 4 over 5. I was like, I know it's supposed to be 4 over 5, but what do I have to do? And it's like if you divide each of them by 14.5, then you get 4 for this one and 5 for this one. Which, I mean, it does make sense, but it just took a little bit to figure out what the number was. All right. One more. So like I said, if you don't put your focus anywhere else when you study, focus on this 19 through 23 because the question on the quiz review is very similar to this. It's just not written as 5 separate questions. It's like one question asking you like 3 different things to do. Tuesday. All right, last one, 40. 2 polygons are similar. Find the values of x and y. So we've got all these given values here. and we're solving for x and y. So we haven't really talked about solving for the angles yet, so let's start with x, the side length, and then we'll go into that. So how would I set up to solve for x here? Any ideas?
22 equals x plus 4.
They're not equal, so they're two different sizes.
X over X plus 4 over 22.
Is equal to what?
2.
Yeah, so initially 12 over 18, but we can take them out by divide a 6 out, so that would be 2 over 3 reduced.
And then after that, you multiply by 22, right?
Yep, multiply by 22. So then I'm left with x plus 4 on the left is equal to,
66 and 44.
yep, or
44.
44 over 3, yeah. I was like, wait, I multiplied the 2 also.
Yeah,
44 over 3, and then we would need to subtract over here, so minus 4. Now I need to get a common denominator though.
so you multiply it by
Yep, multiply this by 3 over 3.
12 then?
So then this would be, I'm going to write it here, 44 over 3 minus 12 over 3. And that reduces, or gives us what?
38. No, 32.
32 over 3. And you can either leave it here, or we can take it and we can
Reduce it.
reduce it down. Or not reduce it. Write it as like a mixed number or decimal.
I think we should
It's.
10.66.
Yeah.
It would just be 10 and 2/3 or 10.66. Yeah. So this would be your x value here. Now the y value. We have to think back a little bit to maybe even before Christmas. What do we know about the angles inside of this polygon?
Opposite angles are congruent.
They all equal 360.
Single line would be.
Opposite angles. What do you mean opposite angles are congruent?
It's also interior. Consecutive interior angles.
Okay, what do we know about that? What do we know about those?
They're always 180.
They're always 180. So I need to find this angle here in order for me to help find this one. So how would I find this angle?
You have to reduce the 60 down to what the other angle would be the first, right?
180 minus 60. So that would be 120 degrees. So this angle here is 120 degrees. In similar triangles, what's true about their, or I keep saying triangles, y'all just know that I mean whatever shape it is. What's true about the angles? Go back to the very first question we did as an example. Huh? What's true about the angles in similar shapes? They're congruent. So what does that mean about y?
Oh, it's 120 as well.
Yep. That means that y also has to be
Okay, so
120.
percent is a degree angle, not a number.
Huh?
Like how 12 is.
Yeah.
I was trying to put the ratio in somehow. That was very wrong.
All right. Any questions on this? Okay. Problems. 11.
Just 11. I would
17. 24 through 28. So that's going to be just like the one that we did. There's like one slight difference in it, but the overall type of problem is the same. And then 39. So that's not that many. I think you'll be okay.